Okay. So make sure you have a highlighter. So we're starting a new unit called quadratic functions. So we're going to review what a function is today. We're going to review a little bit of stuff we learned from lines, and then we're going to look at what a quadratic looks like. Okay, and how do we spot a quadratic? We're actually doing a double lesson today. So we're going to do lesson 1 and 2, and then tomorrow is going to be a homework period. Okay? Okay, so much of mathematics involves a search for patterns and relationships. We're going to skip down to what is a relation. Well, what other word has relation in it? Relationship. And so a relation is when we have a relationship between two sets of objects. So we can highlight that. So a relation is when we have two sets and we have some relationship, something that's connecting one set with another set. Okay, there has to be some sort of connection. If I look at brown-haired people and blue eyes, but I don't talk about, okay, I want to have a relationship between those two pieces of data, it doesn't matter. Okay, it has to be related in some way. So in previous courses, we represent the relationship between two quantities in many ways. So we talked about, you did bar graphs, we did lines last year, right, equations. And so we're going to look at a very specific type of relation in this unit, and that's one of quadratic or parabola. So we're moving away from lines into a very curved graph. Okay, so let's look at this guy. Now we're going to review some terminology that we covered last year. And that one is, before we get to anything, let's talk about how these equations are alike and how they are different. Okay? So looking at them, what's similar to both equations? Look on my desk. They both have an x and they both have a y. So both have an x and y. So it means they both have an input and an output. X is the input, y is the output. Yeah, so they both have an x and y. So what about the way the equations look? How do they both start off? Both y equals. Okay, so how are they different? What sets one apart from the other? The x squared versus 3x. So how do we define that? Do you remember the word that we used? It starts with a D. Degree. So equation 1 has degree 1. Why? Because if we look at the exponents on the variable, the highest power is 1. Equation 2, y is power of 1, but x is power of 2. The highest power in that equation is 2. When we classify degree, we classify it based on the highest power. So equation 2 is degree 2. Yeah. Because of the highest exponent on the variable is 2. And that's really, that concept of degree is really important because all quadratics were going to be degree 2. All linear equations we studied last year were degree 1. So use the equations to complete the table of values. So we have an equation, y equals 3x plus 5. So they give us different inputs. X is the input, y is going to be the output. So how do we figure out y when x is negative 3? 3 times negative 3 plus 5. Negative 9 plus 5 is negative 4. Okay, let's do that for 1 now. 3 times negative 1 plus 5. Negative 3 plus 5 is positive 2. Okay, 3 times now the new x is 1 is 8. 3 times 3 plus 5. 9 plus 5 is 14. And 20. Good job. Okay, so same idea for a quadratic function, right? They give us some inputs, some x's, and we're going to find the output, the y. So for this first guy, negative 4 squared plus 4. What happens when we square a negative? becomes positive. Negative 4 times negative 4, positive 16 plus 4, or 20. Okay, so on your calculator, it's really important that when you square a negative, you put it in brackets, because you want to square the negative 4. So negative 4 squared has to be in brackets, because if you don't put it in brackets, then it's actually just squaring the 4 and then timesing it by negative 1. But we want negative 4 times negative 4. And negative 4 times negative 4 is definitely positive 16. Okay, so the next one, negative 2 squared. So notice whenever I put in an x, we put it in brackets. Sub in that x is negative 2, so it's in brackets. Negative 2 squared plus 4. What's negative 2 squared? Positive 4 plus 4, 8. Okay. 0 squared plus 4, 4. 2 squared plus 4, 8 again. 3 squared plus 4, 13. And 4 squared plus 4, 20 again. What do you notice? Do you notice a pattern with the squares? Well, we didn't have a negative 3 though, right? But if you look at negative 4, positive 4, same y. Negative 2, positive 2, same y. They just didn't put one in. If we put one in, do you think it would be positive 13? Yeah. It would, yeah. Okay, so turn the page over. So we're going to use the table of values on the previous page, and we're going to plot those points. So we're going to have to use the points from the previous page. So on our first point was negative 3, negative 4. So we're going to plot the data. So when x is negative 3, y was negative 4. So we had x, y, negative 3, and negative 4 was the first one. So let's plot that. When x is negative 3, so negative 3, remember, to the left on the horizontal axis, and then down 4. So right there. Okay. Negative 1 and 2 was the next point. So when x is negative 1, y is 2. Okay, so go ahead and plot the rest of those points. You're going to have to turn over the page to figure out what those points were. 1 and 8. So x is negative 1, y is 2. So it means left 1, up 2. And we had 3 and 14. And 5 and 20. Are we going to connect those points? Yeah, whenever you have an equation, y equals, we always connect the points. Yeah? 3, 14. 5 and 20. 1 and 8. 1 and 8. 1 and 8, not 0 and 8. Yeah. Good job. Okay, so let's, if you have a ruler or the side of your calculator, we want to connect those to make a straight line. Now they should all connect. If they don't connect, something went wrong. We plotted something wrong if it didn't connect. So right now, it looks like I have an issue, right? Because not everything connected. That very first point, I plotted wrong. Because x was negative 3, y was negative 4. So that was, here's your 0, negative 3, negative 4 is right here. Now it's on it. I accidentally did negative 4, negative 4. Because it all should be on the straight line. Okay? So let's plot the points and see what happens with the quadratics. I want you to take the points from the previous page and plot this guy. So the points were negative 4 and 20. I'll write them down here. Negative 2 and 8. 0, 4. 2, 8. 3, 13. 4, 20. and 20, 3 and 13, and 4 and 20. Okay, does this form a straight line? Definitely not. So we're gonna, yeah, it's kind of like a V. We're always gonna connect the dots with a curve. If it's not a line, we use a curve. It's a very soft curve. We don't want anything abrupt. So we're gonna connect these. Okay, yeah, there you go. So connect it with a soft curve. And so that is whenever we have a degree 2, it looks like that shape. So what shape does it kind of look like? More like a U. Then a V is a little bit more sharper edge. Absolute value graphs, one day we'll learn about absolute value, those are V's. So quadratics or degree 2s are always going to be like a U. So a U like this. Okay, so that's a quadratic. All right, so does everyone have that plotted? Good. Okay, so in what ways are the graphs alike? So what were they? How are they similar and above? They're both graphs and they're continuous lines. Right? They're both, the points could be connected. They're both continuous. And how are they different? The equation 1, yeah, so equation 1 was a straight line. Equation 1. Equation 2 is curved. Curved like a U or a U shape. Not really. I don't know what you mean by that. Yeah. Okay, so a little review of domain and range. So remember, another way to remember which one's which is Dr. XY. Or D comes before R like X comes before Y. So Dr. XY, domain is for X, range is for Y. Okay? Dr. XYZ. You can add a Z in there if you want. Just call me Dr. XYZ. Okay, so I made that one up. Okay, so the domain of the relation has to do with the input or the x values. So all the location of the x values, the independent variable. So when we find the domain, which is the x, we ask how far, remember that? Which direction? Up and down or left and right? Left and right. How far left and right? And range then would be how far up and down. So range, how far up and down, because range is with y. Y is vertical axis. So how far up and down? Can you see, Emsa? Yeah, okay. I made it up. I thought, oh, that's cool. Yeah. Interesting. Gonna make my head go big. Okay, so state the domain of the first graph. So looking at the first graph, how far left will this graph go? Will it keep going to the left as the graph goes on? If it's angled, yeah. Will it keep going to the right? Yeah. So how do we write if it's everything? If it keeps real, right? X is an element of the reals. How about XER? XER, X is an element of the reals. How about this guy? Will this guy keep going to the left as the graph goes on? Will it keep going to the right? Yeah, it's angled both ways. So that would be XER. So they both have the same domain. There's no restrictions on our X. Remember, in radicals, there is restrictions, right? You couldn't have the negatives. But in both of these equations, there are no restrictions. Let's look at the range, though. No. It just, you need to just be able to say that. Like, look at the graph and say what the domain is. Where's the location of the graph? Well, it's going to be forever to the left and right. Yeah. Right. Yes. Right, so that's going to be the up and down part is our range. So when we classify the range, you said when the graph, it's going to keep going up and it's going to keep going down. So it's going to be YER. It goes forever up and down. So that for the line, yeah, that's going to be Y is an element of the reals. Oh, I wrote in the wrong spot. Whoop. Oh, yeah, right. You didn't even write it, Dean. Okay.
I wrote it. Look at that.
So, well, we'll do another one right here. How do you write this guy? What other one? So it's either written as an equality or it's XER. So here's it's going to be an inequality, right? Because the graph, where does this graph start? 4. It starts at 4 and then it keeps going up. So we would say Y is it above 4 or below 4? Above. Above meaning greater. So Y is greater than or equal to 4. So remember writing this, Y is greater than or equal to 4 is the range of our, whenever we have a quadratic, it's your range. Domain's always going to be XER. You're going to have to figure out the max or the min value to figure out your range. Okay? So a functional relation or function is a special type of relation which when each value in the domain is only one value in the range. So that, remember when we did graphs last year? And say if we had a circle, we asked, is it a function? And we did a test. Remember what that test was? We drew a vertical line, the vertical line test. And if it ever crossed more than once, was it a function? Not a function. Okay, so because a function, each x has only one y, right? So each element of the domain, which is your x, has only one element in the range, has only one y. So that's the definition of a function, just to review. Now, are both of these functions, if we did a vertical line test? If I drew a vertical line, will it only ever cross this graph once? The first graph. Yeah, it's a function. How about the second guy? Yeah, it is also a function. So they're both functions, and quadratics are always going to be a type of function, which is why we call them quadratic functions, and why the title of this unit is called quadratic functions. They're all functions. Okay, let's highlight that last bit there. So which represent functions? They both do. We did the vertical line test to figure that out. And so a function right here, this last bit, is a special type of relation. A special type of relation that when each x has only one y. Each input is only one output. You put money in the vending machine, only one thing comes out. Doesn't get confused and then two things come out. You wish, but you relate. You missed the explanation. Okay. So a linear function is a function whose graph is a line. We studied those last year. So a quadratic function is a function whose graph is U-shaped. It either opens up or it opens down. So it's going to be either like a smiley face or a sad face. Okay. So this guy, the first guy we say opens up. Opens up. And the second we would say opens down. Yeah, and there's a certain value in the equation. If it opens up, it'll be positive, and we'll talk about that value in a second. Okay, so we're going to go through each one. We need to grab your graphing calculator. We're going to graph it, do a rough sketch, and say if it's either linear, quadratic, or neither. Every single one. So we're going to do it together. Grab your graphing calculators. And go to y equals, one at a time. Make sure your windows are normal. So 3x plus 1